and maximum number of nodes between critical points. Now, again, we have already seen similar kind of problems on a simple array. It is just that now this problem is on a linked list. It simply says that a critical point in a linked list is defined as either a local maxima or a local minima. Now, for the folks who don't know what a local maxima or local minima is, they have defined what a local maxima is and what a local minima is. For them, or in general, the local maxima is that if the current node value it is higher than the previous node value and higher than the next node value. Now, the same way vice versa is for local minima, that the current node value is lesser than the previous node value is lesser than the next node value. This is my local minima. So remember, these two things in turn gives these two conditions. Now we have to note that like a node can only be a local maxima minima if there exist both a previous node and a next node. That is a condition which is given in some problems and are not given in some problems. Now what is the inference of this condition is that if I have an array, it means to even name a element or a point as a local minima or local maxima, I should have both its previous and its next element. So you will see in some problem, if this condition is not given, you might also end up considering this point, which means the extreme end point. If its right is higher, then you might end up considering it as a local minima. But in this case, they are saying that you should have both the points, which means the extreme end points will never be my critical point. Now, what is this critical point? The critical point is any point which is either a local maxima or a local minima. And they have defined also that critical point is the point having local maximum, local minima. Now, the condition is that given the linked list head, you know that we are always given the head of a linked list, return an array of length 2 containing minimum distance, maximum distance. What this is? So you are given the linked list. Let's represent this linked list as an array for now. You have to find the minimum distance and the maximum distance. Now they are referring, what does the minimum distance mean? Minimum distance is the minimum distance between any two distinct critical points. You know, let's say that I have this array in which I for sure know that these points can never be my local maximum, local minima. Let us imagine that this point was my local minima. Let's imagine this point was my local maxima. Let's imagine this point was my local maxima. So we figured out that these points are the only critical points in this entire array. Now they are referring, you have to find the minimum distance between any two distinct critical points. So imagine that you had an array of a size n. So obviously in worst case you could have n critical points. Now if I go and ask you to find the minimum distance and the maximum distance between any two critical point, you might end up going and trying for all the n square points, which is obviously is not a good thing considering that the number of nodes can be 1e5. So if you go and try for all the n square pairs, it will give you TLE. Thus, you have to look for something better as in either of O of n log n or O of n. But now in this case, you saw a very standard approach. What is that? You have to find the distance. You have to find the distance. So while I was checking that, okay, it's a distance between any two critical points. So let's imagine, let's number the indexes 0, 1, 2, 3, 4, 5, and 6, and 7. Now, why I numbered them is because if I just go and check the distance between these three, it is 3 minus 1 plus 1. The distance between these is 6 minus 1 plus 1. Okay. So the inference, what we could see from this diagram also is that earlier what could have happened with this n square combinations is that for a point C1, I would have gone and tried for points C2 and C3 to grab what? Firstly, minimum distance, and secondly, maximum distance. I would minimize my minimum distance, maximize my maximum distance. Now, let's firstly focus on figuring out the minimum distance between any two critical points. Next, then we will go to maximum. If we have to figure out the minimum distance, we are at a point C1. I was going and trying for a point C2 and C3. Isn't it very obvious that the nearest point to C1 will be the contributor to its minimizing, like to minimize its result? Isn't it? Obviously C3 is after, like it is far away from C1, which means nearer to C1 I have a C2. So obviously I will never have my C3 which will contribute in minimizing the minimum distance from C1. So okay, which means that this path was redundant, or it is just one path. What about I had C4, C5, C6? All of them are redundant. I only want my nearest critical points to get to my, or to basically leverage that in minimizing my minimum answer or minimum distance. Okay, so from this thing we realized that considering I have, let's say, 5 critical points C1, C2, C3, C4 and C5. To minimize my answer, I will take the minimum distance here and here, minimum distance here and here, minimum distance here and here, minimum distance here, and this, okay, nothing like here on the right, so nothing, and here also nothing on the right, like left, nothing. So you realized ultimately, again, it is repeating, so let's remove it. It is repeating, let's remove it. It is repeating, let's remove it. So ultimately we realized that we are trying to take, the distance between every two consecutive critical points, and that is the candidate in minimizing our minimum distance. So let's imagine its index is 1, its index is 3, its index is 6, its index is, let's say, 7, its index is, let's say, 14. So here the distance was, let's say, again, for now, let's say the distance is 3 minus 1 plus 1, which is my 3. Here the distance is my 4. Here the distance is my 2. Here the distance is my 8. Minimum distance was my 2, and that is my answer. Cool. Okay, so we have, and again, it is just that finding a critical point is very easy, because we saw that it can have this condition or this condition. If any of the condition follow, I will get the critical point. So for that, I need to figure out a critical point. I need to check either it's a local maxima or local minima, and for any of them, any of the local maxima or local minima, I need to know my current node, I need to know my previous node, I need to know my next node. So these three variables I will keep track of. Okay, then when I will keep track of these variables, if I am at this specific id as an index, I should know the index of my previous critical point. So I can say it as prev critical point, because until and unless I know my previous critical point, I will not be able to find the difference in their specific distance. Cool. Again, if you see and look back by the examples what they have given, they have taken the distance as 3 minus 1, which is 2, 6 minus 3, which is 3, and 7 minus 6, which is 1, 14 minus 7, which is 7. So like they have not taken the actual distance, which is in terms of complete thing. They have just taken the difference of the indexes. Again, both are completely fine. You should go about how the problem wants you to go about. Now, okay, so we realized we need so far these three variables and my current index as one variable and my previous critical point also as one variable. Okay, but so far we have only found out the minimum absolute difference. What about the maximum? The same we can infer for maximum, that for a point C1, I had C2, C3, C4 and C5. It is obvious that I should go and try for the farthest point. I should not go and try for all these points. Okay, then you might repeat the same thing for C2, but C2, then you might go and end up checking for C1 and C5. But then my argument will be very, very, very simple. you can see that a C1, a C5 will always be farther than any other point inside to the extreme points. Any other point inside to the extreme points. So this will always be farther. So my maximum distance will be achievable if I take my first critical point and my last critical point. Okay, so we realize that we need one more variable, which will be my first critical point. And whenever I am at any specific index ID, I will check my distance with the first critical point. Now you might ask, Aryan, isn't it same? Like previous critical point is same? No. For any specific ID, let's say ID is here, previous critical point is this. Previous critical point is this, but the first critical point will remain as it is and will point to my first critical point only. So to minimize my answer, I will be doing a ID minus previous critical point. To maximize my answer, I will be doing ID minus first critical point. And ultimately, I know ultimately in the end, my actual answer for maximum distance will be contributed by last critical point when I will do subtraction with my first critical point. So that is how I will get my answer. And again, every of this process, which means finding a critical point by using these three variables and using them to minimize or maximize your distance, can be done in just one pass. If we are iterating on this, if I'm on a specific index, I will check its previous and the next. I will know it's a critical point or not. I will check what is my previous critical point. I will also maintain my first critical point whenever the first I will achieve it, and then by this I will get the answer. Cool. Let's see the code again. You see that this is called as a greedy approach, that you greedily choose the nearest index, you greedily choose the farthest index, just so as to minimize or maximize your answer. Cool. Now let's see the code. It's exactly same what we discussed. Firstly, we want to return an answer in which you have to minimize the minimum distance and maximize my maximum distance. So I've initialized my minimum distance with the maximum value and minimum distance with my, maximum distance with my minimum value. Now I have just received my current node. So as I can iterate on the entire linked list, I told you I need three variables, which is previous critical index, first critical index, my previous node, and you will see I will also need my current node and my next node. All these variables I will need. And here, as soon as again in the very beginning of my linked list, my ID, let's say index is 0. Again, I'm just trying to infer that linked list as an array only. So if this index is 0, I know that this can never be my critical point. So I will always start off and do it from the next index. So I will say that move the current to the next index. So now my current is pointing here because I know this is the first valid candidate or can be a valid candidate for my critical point. Thus, I will simply go and check. I will again go and check, do I have a next element or not? And if yes, which means now I can consider this and I can try for it being critical point, because I know I will for sure have previous because I had already done a next. I know I will for sure have a next because of my while loop. My while loop will keep on trying. If I have a next, then only keep on trying in the array. Now when this portion is done, which means you have a next, you know that your ID was 0, but at this point at the current your ID will be 1, so increase your ID. So I have increased my ID. I have received my previous node value, just previous node value, which is above. I have my current node value, which is right now, and I will also have my next node value, which is just saying current's next value. Now you will have to check if this is either a local minima or a local maxima. So for that, I will first check if it's a local maxima, just comparing with the previous and next node, or it should be a local minima. If any of this case is there, which means that this is a critical point. So firstly I will check, is it the first critical point? So in the very beginning, my first critical index was -1. So if it is a -1, which means there is no possible index -1 in the entire array when the indexing itself started from a value of 0. So which means that if the first critical index is -1, which means this is the first index which came as a critical point. If that is a if that's the case, I will simply assign my first critical index as id, and also my previous critical index as also id. Again, you don't need to put it here, you don't need to put it here, you can put it like after is a if else condition, you can also put it here, that previous critical point is also equal to id. It is just that every time I receive a critical point, for the next iteration, I should make sure I have the information of my previous critical point. Cool. That is the reason I am assigning it in the end, that in the next iteration, whenever I receive the next critical point, I should be having the information of my previous critical point. It is not the previous node, nah, is the previous critical point. So then I went on and checked, okay, if it is a first, then allot the values for the first time. If it is not the first, which means I can minimize my answer and maximize my answer. Although here you will see that maximizing your answer will always and always be impacted by the extreme end critical point and the first critical point, but still this id will ultimately in the end will touch the extreme end critical point. That's the reason I can just put it id here. Although if you want, you can also say that in the very end, when you return the answer, your answer will be last critical point minus first critical point. So in this case, what I did was I minimized my distance by saying current index, or I should say current critical point minus my previous critical point or index, and maximizing my answer by the current index minus the first critical point. Thus, I will be having my minimum and maximum distance. Now simply make sure to assign your previous critical point as the current index, so that next time it helps you. Now ultimately, when this if loop is done, you have to make sure, even if it is not, even if this if loop is not executed, you still have to go on to the next node, for which the previous node should be equal to the current node, and then ultimately move to your next node. And thus this while loop will keep on repeating until you have your next node there. Ultimately in this you will have your answer. If the answer is still int max, which means the by default value, which means you were never able to get the answer, in that case simply return -1, else return the answer. And with that case, in just one pass you achieved your answer, and for sure there is no extra space used because you never use any extra space. So your answer is O of 1, and that is your answer. Cool. I hope you guys got it. If yes, then do smash the like button. It helps me motivate a lot. Goodbye. Take care. Bye bye.